Software testing is to identify errors, faults, and missing requirements, a functionality issue, performance issue, and then security. Security is very key in every system that we develop, especially if you are dealing with mission critical applications. An example could be a banking system. If you don't protect the data of your users, someone might steal the data and use it for something bad that may ruin the reputation of your business. So that is yeah, that is it for the purpose. Why do we do software testing, or why software testing? When we say software testing helps save lives and properties. So I have some images here. So imagine you bought a car. Cars run on softwares, right? So if the manufacturer of the car assembles the parts of the car and then installs the software on their car, and then they don't test the car thoroughly to make sure that it's working well with the hardwares and everything is going as expected, and you go and buy the car, there's that probability that you might, get an accident, and which may lead to loss of lives and then properties. And another example is an aeroplane. We all enjoy being in an aeroplane or traveling in an aeroplane. So imagine an aeroplane is manufactured and then the software system on it wasn't tested thoroughly with the hardware, so probably the software itself wasn't tested thoroughly to make sure that it meets the expectation of the requirements. Then people may lose their lives in the process. Another thing is save cost. When someone loses their life, that is cost. Or maybe when properties get destroyed, that is cost. So once you start or you do software testing in the development process, you save all these unforeseen circumstances from happening, and then you save your money. And moreover, you also protect your business from bad publicity, or you save your business from bad reputation. Compliance and standards. It depends on the industry you are in, especially when you are in the banking and financial industry. It is very important you put in place certain measures to protect your clients or your customers. So software testers come in there to make sure that all these compliance and standard measures are met, so that the end user enjoys using your application and they are able to use your app or your system to deliver whatever tasks that they intend to do with your system. We also do software testing to identify poor design and implementation. I think this is where usability testing also comes in. So once you've launched your product, maybe a beta version, and then you give it to a group of people to test, the experience that they go through with your app or your functionality helps you refine it. It helps you identify the poor designs and functionalities in there, so that once you release the final products, customers will enjoy using it. There are lots of products out there that people don't even use certain functionalities, right? So the usability testing, or maybe identifying, doing testing helps you identify the poor designs and implementation decisions. We also do testing to check valid and incorrect functionality. We also do testing to check security and scalability issues. When we say scalability issues, we are talking about situations where maybe you built a system and then you are saying that the system can handle, let's say, 1,000 load within a particular time frame, right? Once you test that and you know that, okay, this system that I've built can handle this load, there are situations where the load on the system would be more than 1,000. So how would the system handle all those scenarios, right? So software testers come in there to make sure that they test the system thoroughly, so that the system we are able to get relevant data or reports on how the system will behave when they are on high loads, or maybe their scale In software testing, we live by some principles, right? Which are the 7 testing principles. The first one is testing shows the presence of defects. Yeah, so testing is a psychology, right? As a tester, your main aim is to find bugs. Your main aim is to fish out issues in the system, not to verify that the functionality is working. You are there to break the system, right? So testing shows presence of defects and cannot prove the absence of defects. The second one is exhaustive testing is impossible. You cannot say you've done 100% testing, so your system is bug-free. No. There are situations where even experienced testers have tested the system and then they've learned it, but then on production, they start to encounter certain issues, right? So exhaustive testing is something that is impossible. Early testing is very important when it comes to product development. So as a product manager, that is where I think Agile also does very well. Because with Agile, once we use Kanban boards, especially when you're doing a Scrum, you use tools like the Kanban board to track the various tasks. And whilst tasks are being assigned to developers, similar tasks are being assigned to testers to test those features and functionalities. So testers get to engage in early testing, and then if you engage in early testing, you come across issues early and you resolve them early, which saves time and then costs. Defect clustering. There's nothing like an equal distribution of bugs. This means when you're testing a system, let's say you are testing a login system and you come across issues on a login, let's say one bug on the login system, right? It means that area can be a bug infested area. So you have to debug that area and make sure that you fish out all those hidden bugs for developers to resolve, right? So that's the defect clustering. So when you find a bug in a particular area, it means there are potential bugs around that particular area. Moreover, when you say equal distribution of bugs, you don't say, oh, because I tested the login system and then I realized there are a lot of bugs on the login system. When I go to the registration system, I'll get similar issues on the registration system. It doesn't work that way, right? So that is the defect clustering. Testing is context dependent. Testing is context dependent. Different websites are tested differently. So an example is, you cannot say, I have 2 years experience in testing LMS, maybe a learning management system. And then you're going to use that same strategy to test a banking system. It doesn't work that way. Testing is context driven. So if you are testing a banking system, the strategies and tools you use to test the banking system is different from the strategies and the tools you use to test an LMS system. Pesticide paradox. Executing same test cases again and again will not help. So most of the times, especially with those who do test automation, most of the times when you write a code to test a particular functionality, you are like, oh, as for this code, it is 100%. I think it's checking all the possible scenarios that I have drafted to meet the requirement. But then that's where the pesticide paradox comes in. You feel confident about the test that you've written, which is very bad, because with testing, anytime you go into your code base or anytime you check your test cases, there's always something you can do to improve your test case. Moreover, in the development phase, there may be changes in requirements, especially when you are in an agile organization. So the change in requirements, once they come and developers commit to them and then deliver those changes, you have to go back and modify your code to meet the new requirements. Absence of error is a fallacy. The measurement of quality is when the customer is satisfied. When the product is in the customer is using it and they are satisfied. That is the measurement of quality. So after testing or after developing a product, you cannot say, oh, I have tested these products and then there's no error or there are no bugs. the customer is the one to determine that, oh, this particular platform or system is of use to me, right? So meaning they are satisfied with the system, right? Yeah, so basically these are the 7 principles of software testing. When it comes to the software development lifecycle, we have, or maybe development lifecycle, we have the software development lifecycle, and then we have the software testing lifecycle. Like I stated earlier, before we develop a system, we have the requirement analysis phase, we have the software design phase, which is where the product designers or the UI designers come in to design based on the requirements. And then we have the software build, the testing, the deployment, and then the maintenance. And then with the software testing life cycle, we have the test planning, we have the test case development, test environment setup, test execution, and then test closure. So whilst the product designers are working on the designs for the products, software testers are documenting or they are writing their test plans. So the test plans contains the scope, the strategies, and the tools that they are going to need to test a particular system, right? So whilst the UI designer is working on the UI or the product design, the software testers are working in collaboration with the developers and stakeholders on the test plan. After the test plan has been approved and the necessary tools have been availed to the software testing team, they start working on their test cases. They start developing their test cases. So the test cases basically are based on scenarios. So we put ourselves in the shoes of the end user to test in accordance with the requirements. And then the test environment setup is maybe you are doing automation, or probably you are doing manual testing. If you are doing automation, you may be using tools like maybe Selenium or Cypress. You have to set up the environment and make it ready to test for those test cases that you developed. If you are doing manual testing, you probably have your test cases done, and then you execute them manually once those models are ready and available to you, so that you document them as needed. Then the test closure comes in. When it comes to testing, there are two main testing types that organizations use. We have manual and then automation. Some organizations do only manual testing, and others blend both. Others also do just automation testing. So the manual testing is when you manually go through the application using the requirements. You manually go through the application to see or to test that the application is meeting the expected requirements, right? So let's say we are building a system with a, let's say an LMS with a login system, right? The login system has its requirements. And even with the requirements, each field or each component on the login system would have its rules, right? So an example is a login system with an email and then a password field and a button. The email input field will not accept any character that does not represent an email, right? An email input field should not be empty. A password input field could have rules like special characters, no spacing, numbers, uppercase letters. Like these are rules for the login system. So once you are doing the manual testing, you use the requirements to test against this to make sure that the software product or the feature is meeting the requirements. Now let's go to levels of testing. When it comes to software testing, we have 4 main levels of testing. We have the unit testing, integration testing, system testing, and then acceptance testing. With unit testing, you test individual components or individual units of the system to make sure that they are working as expected. So an example could be, like I said, the login system. So the email input field is a unit of the login page. So it has to be tested thoroughly against the rules or the requirements to make sure that that email input field is working or functioning as expected. So if it doesn't have to take, let's say, an empty value, you test to make sure that the email input field is not empty before a user tries to initiate, let's say, a login. Integration testing is where you test, you combine two models to test. So let's say you have, you are testing a banking system. So you have the current account balance model, and then we have the transfer model. The current accounts model working with the transfer model is an integration test, right? So that is it for the integration test. And then with the system testing, that is where you test the complete system. So when the whole system is ready and probably about to be launched to the markets, we do system testing to make sure that everything is functioning as expected. And you have the acceptance test. Acceptance test, which is more like the beta test or usability testing. After the product is built or complete and we want to release, we can release it to a particular group of customers to engage with the app or use the app and then give us feedback. So once they accept and love using the application, it means they've accepted it, right? It meets their requirements, the user requirements. So they've accepted it. That is the acceptance test. When it comes to software testing, we have so many types. Like I said, organizations use two main types, either manual, automation, or blend both. But then under the manual and then automation, we have white box testing, black box testing, then the gray box testing. When we say white box testing is when the tester understands the frameworks, the requirements, like the technical requirements of the system. If developers are going to use certain plugins to help or aid in developing a particular functionality, the software testers have in-depth understanding and knowledge of those features or plugins, or maybe the framework or language that is being used to build the system. When we talk about the black box testing, that is the manual testing. With that, the tester doesn't need to have an in-depth understanding of the system itself. All they have to know is the system requirements, understanding the requirements and then testing against the requirements. When we say gray box, with the gray box, testers have a fair idea or some idea of the internal workings of the application. So they may have access to the requirements, they may have access to let's say API documentations, they may have access to certain technical requirements that will aid them to perform certain tests, sorry. Under these types of testing, we have the functional and then non-functional testing. Under functional testing, we have unit testing, integration testing, and then many. When we say functional testing, we are looking at the functionality of the application. Most of the times when a client comes to you that, oh, build me a website, most of the times they give you their functional requirement, which is I need a login page, I need a dashboard, I need a user management system or something. So with the user management system itself, it comes with different breakdowns of the functionalities, and these are the functional requirements. Most clients do not give non-functional requirements, but they expect the app to work to meet the non-functional requirements. So an example is performance, security, compatibility, scalability, and then the stress, right? So when we say unit testing is, like I said, is testing the basic units of a model, right, or a system. So an example is like the input field that I made mention of, the email input field. Usually, developers do unit testing, but QAs are also encouraged to do unit testing. With when it comes to developers usually use tools to write unit tests, and they find it very difficult to write those tests because they feel like it is an added task or an added work for them, right? So they use tools like JUnit and the likes to write their unit test. When it comes to integration test, I think I've already explained integration test, testing two models to see how they can effectively work or communicate together. The system testing is like testing the whole system, and then incremental testing. So under integration testing, we have two main types of integration testing. We have incremental and then non-incremental testing. With the incremental testing, we have the top down and then bottom up approach. This is the incremental testing. For example, let's say we are building a banking system, and then we have 2 or 3 developers working on the system. We've discussed the various models that has to be built or that have to be built, and then we've shared it among the developers. Developer A is working on, let's say, the accounts management model. Developer B is working on money transfer model. Developer C is working on maybe a different model, right? Testers would not have to wait for all these models to be complete before they start testing. So they use the incremental testing approach. So as and when a model is ready for testing, then they test. So most of the times, these models depend on other models in order to deliver value. So once you get model A, you simulate or you assume that maybe model B is ready. So let's say you have to log into a system before you can transfer money, right? And then the login system is not built, but then the accounts model is built, so you can see the money. So you create a step to simulate that if a user logs in, they should see requirements A, B, C, and D, right? So from the login to the account model, the login will be a high level requirement or a high level model to be built, but then it's not ready. So with that, we are using the top down approach, right? The bottom up approach. So we are looking at the account, the amount in there, and then the requirements that or the specifications that has to do with the account management system. When it comes to the non-functional requirements, some people call it the big bang testing approach. That's when you wait for all the models to be complete before you do testing, which has proven to be not effective. When it comes to performance testing, we have performance is when you test your system to make sure that users do not waste much time in performing a particular task on the system. So an example could be like logging into a system. So after providing all the details that is required for me to log into a system, it shouldn't take me much time to log into a system. So under performance testing, we have other testing like load testing, stress testing, scalability testing, stability testing. The load testing is when you test your system against the required threshold or the required load. The stress testing is when you test against the extreme scenarios. Scalability testing is when you test your system against situations where there will be so much load or so many users on the system trying to perform a particular task at the same time. And then the stability testing is when you do stress tests to see at what level would your system be stable and at what level would your system break. I've already explained what usability testing is, so let's talk about compatibility. Compatibility is when you test your system against different environments. So an example is you develop a mobile application and then you want to run it on an Android and then an iOS environment. You have to test to see how compatible your app will be on those devices. When it comes to websites too, you can test using different browsers to see how compatible your system will be on those devices. When we say defects or bugs are flaws in a design, right? So when a developer builds a system and then they hand it over to the tester, when the tester comes across issues in the system. That is what they refer to as bugs, meaning there's either an error. An error is maybe a coding mistake or maybe a missing requirement, right? So they bring them up and then send it to the developers to address them. Time is fast spent. Okay, let me talk about this. So the reason why we come across many bugs or there are bugs in system is one, ambiguous requirements. When the requirements are unclear, or maybe the testers or the development team do not understand the requirements, it introduces a bug into the system. Programming errors, like I said, when developers write their code and they don't write it well, or probably there are issues with the code, it brings about errors, which could be termed as bug. Unachievable deadlines. When stakeholders put tight deadlines on you as a product owner to deliver a product to market, then you put that same pressure on your development and testing team, and then they tend to rush things. So some of these things end up introducing bugs into the system in the end. Well, time is okay. A minute. Okay, so since time is fast spent, I would like to talk about test case development, and then we'll move to the last slide. So when it comes to test case development, most organizations, especially when you are new in testing, you have to start from somewhere, and most people start from using Excel documents. And there's a structure to how you have to structure your test cases or develop your test cases. So if you can see what I'm sharing on my slide, you see that I have a test case ID, a test case description, and then I have the tester's name here, and then received by, whether if you have a test manager in your organization, the test manager will be the one to receive it. If you don't have, the PO will be the best person to have access to this. And then the version of the system you are testing. And then this is a tester's log. So here you can see that I've written that the decision table approach was used to develop test cases for the login system. This is a strategy to test login systems, right? To help you check against all possible scenarios. And then here you could see the tester's name, the date that the test was done, and then here indicates whether any of the tests has failed. So even if one of the tests fails here, it means this whole scenario or test case has failed. Then you send it over to the developers to address the issue. So here is test for valid email and valid password, which is the happy approach. So verify that the user is able to log in after entering valid inputs credentials. So when a user enters valid inputs or credentials in your login system, what are the requirements? What should they see? So the preconditions are they navigate to your website, the application is accessible, the user is on the login page, and then login form is visible to the user. So these are preconditions that you have to see before the user can actually take an action. And if you can see here, you can see that enter valid user ID, enter valid password, and then click on the sign in button. And with this, you have to provide valid user details in order to access the system. And then once you do that, the end results, you document everything. If it fails, you document it and probably debug to find out where the issue is coming from. And then you send it over to the developers to look at it and then resolve it. But Excel documents have proven to not be effective because it is stressful for testers to be documenting using the Excel document. So there are tools that have been introduced into the market for managing test cases, right? So if you can see my screen, you can see test row, test pad, test lodge, and a lot. There are many on the market, so you can find out about them and learn more about them. When it comes to automation tools, we have a lot. We have Selenium, we have Cypress, we have Perfecto, we have Protractor. There are a lot on the market. So you can equally look at these tools and then learn more about them to improve your product development life cycle. Before I open up for questions and answers, I'd like to talk about these trainings that we are running as a company. So we have digital product owner training coming on 13th May 2024, which is a workshop. So if you're interested in becoming a product owner, this is the best course for you to, or this is the best opportunity for you to enroll in our training. We also have an agile software development training going on. The links will be dropped in the chat. You can go to our website and learn more about our trainings, and then become an effective product owner or a good quality assurance engineer and earn very good salaries to better your life. Thank you. So at this juncture, I'm going to open up for questions. I'm going to check the chat to see whether they have questions for me. Kindly drop your questions in the chat so that I can attend to them. Time fast spent, so I'm just going to allow some 2 minutes of questions and answers time. So okay, so without any question, like I said, kindly visit our website. We have the links in the chat, and then get to learn more about our trainings. Thank you and have a wonderful day. Bye-bye.